again, this is a perfect series of questions. We're going to go over this one word problem and then look at these two guys here that are going to help us with word problems later on. There's a couple of skills with those things, just in terms of identifying what the information is that's being provided. Starting with this guy here, this is essentially a baby step long answer word problem. What something like this might give you, or a question like this, it may, or on the exam, it wouldn't break it up into like those two discrete parts. It's just going to give you information and then ask you something specific like at what height, blah, 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 blah. The fact that they've included in those two questions, it kind of makes it easier because this is taking out the logic and reasoning that I want you to build. Okay, if that wasn't there, okay, and it said a stone is thrown upward from a height of 4 meters, thrown, and then after 3 seconds reaches the max height. If they just gave you that, and then like the final part, question number 2, you would have to reason through and figure out basically what the height is so you can get your K, so you can plug this guy in to the vertex form to be able to find the X value. So if you didn't understand any of that, all I'm saying is this guy right here is the part that you're going to have to develop. This question is giving it to you. What maximum height reached by the stone? This second question is a lot easier once you get that guy. Okay, but if I don't have it, then I can't get down to the end, and it may be your roadblock. So that's the biggest thing we've got to work on. The most impossible thing in the world is to try and teach people how to think critically, but that's what we're just going to do here. So let's start by just looking at what information is being provided. I am going to draw on this everything that I know now. Okay, and I do want you to use the diagrams if they are provided. If there is a diagram, I want you to sketch it up. If you're sitting there and you're staring at it and you don't know what to do, the first thing I'd like you to do is start to do things like that. That's not just 4, that's 0 and 4. I might be able to use that as a point now that I've identified it as a point and not just a 4. This guy here is going to be 8 and 0. Okay? So if he's 8 and 0, perfect, that's fine. I may have to use him as a point, may use him as a 0, not entirely sure yet. This 3 right here, all that's suggesting is that my H value is 3. And we talked about this guy yesterday a little bit. If you get to this stage of it, and we start to list out the things that we know, A, H, K, X, Y, Z1, Z2, and Y-intercept. So I have a Y-intercept of 0 and 4. I have my second 0 of 8 and 0. I have a point of 0 and 4 that I could potentially use. And I have an H of 3. What form am I going to be working in? And do I have enough information at this moment to solve this question? No, right? I don't have enough information right now. I would need either the K or the first 0. So that's the critical thinking that I want you to do. Once you label this here and you're like, I'm stuck. Well, what you should be thinking is, what are the 2 things that I need to be looking for and can I get them? So can I figure out what the K is of this guy right here? No. In fact, I can see here, number 1 is actually saying, what is the maximum height reached by the stone? That's actually asking me, what is the K of this question? So I can't find K, which means there must be a way for me to find the second 0. And Alex, you sniffed this one out yesterday. Because H, the distance between H and that second 0 is 5. Okay? That means this distance also has to be 5. So you can use logic and reasoning to identify that the first 0 would be -2 and 0. -2 and 0. Now I know I'm going to be working in zeros form. So if like number one, we label everything. So this includes over here, like my label of, you can say identify everything that it is that you have, because then step two, I can go ahead and say, I'm going to find A in zeros form. So y is equal to A, x minus z1, x minus z2. And now I can use that 0 and 4 that I found. 0 plus 2, 0 minus 8. Now I can just do my math and solve for my A. Relatively easy step. A2, negative 8, negative 16. And negative 16, so A will be equal to negative 0.25. Now, if you made a mistake there with the negatives and you ended up with a positive, your diagram is what you're going to look to. And whenever I solve for A, I'm always going to go take a look at the diagram and ensure that the shape of the parabola or the direction of the parabola matches the A value. And because I got a negative, I know that I'm good. So perfect. I now have the rule. Y is equal to negative 0.25, x plus 2, x minus 8. Problem. I can't solve for x values in this form, right? So I have to be able to convert it. And again, my suggestion is always, if you can, convert it to vertex form because it makes your life easier. And we already have the h. So finding this guy in vertex form is not going to be that bad, right? All I'm going to have to do is just say, okay, using this rule, my k is going to be equal to negative 0.25, 3 plus 2, 3 minus 8. Because I'm just plugging in the h value, right? I'm just plugging in the h value in that case. Did you want me to put like the little formula there that you would have taken it from? That's still the zeros form. And so the option right now is, if you wanted to, you could FOIL that, right? And then multiply everything by negative 0.25 and then deal with it in general form and then use the quadratic equation to solve for this part here. But because step one is saying what is the max height, and because I already have what my h is, so I didn't even need to do z1 plus z2 divided by 2 to get it. I already had it. Why not just try and find k, and then I'll be able to convert it into vertex form. As soon as I get k, I will have a hk, so I'll have it in vertex form. So k is equal to negative 0.25 times 5 times negative 5. So it should be a positive value, and then what's 1/4 of 25? 6.25 or something? What is it? Is that what it is? Yeah. So then k is positive 6.25. So that means now I actually have my rule. Like, I'm going to just use different colors here. I found this guy, negative 0.25. I found this guy, positive 6.25. So now I can switch and work in a form that I know is going to be useful for me. So the maximum height, k was equal to 6.25. That question's done. Now, I'll reiterate it, this is the hardest part of the year. If you can wrap your brain around this, you're doing awesome. So determine the elapsed time from the moment the stone was at a height of 2.25 meters during its descent to the moment it hit the ground. Okay, so I'm going to use step 4, find x when y is equal to 2.25. Okay? Now there's two ways to solve for this. Cameron, eyeballs up, buddy. There's two ways to solve for this. Okay? So let's do option 1, which is h plus or minus square root of negative k over a. Okay? So option 1, I'm going to take my rule, y is equal to negative 0.25 x minus 3 squared plus 6.25. Okay? My first option is using this guy here. Originally, we just used h plus or minus square root of negative k over a to find out my zeros. But I can still use that formula to find for any x's, right? X's. So I can say that I'm solving for my two values of x, right? When y is 2.25. So just to reiterate here, I found my a, I found my h from the diagram, I was able to solve for my k. I have the rule. The question's asking me to solve for what is x when y is 2.25. Do you have any questions about that part in terms of how I got to there? Why I put the 2.25 on that side? We're good with that? Okay. If I want to use the h plus or minus square root of negative k over a, I am going to have to modify this equation, or I'm just going to write it right here, a phrase that we've already heard, set to 0. As in, this guy has to come over here and the equation needs to be set to 0. Then it's going to work, right? Then this guy is going to work. So, did the a change? No. Did the h change? No. The k certainly did. That's a y value, okay? So now I have a clear a, h, and a modified k. So that guy is still my k, but I modified him so that instead of looking for the zeros, let's say this is the x-axis, now I've shifted the line up and I'm looking for what is x when y is 2.25. Does that make sense? It's still a k, it's just modified, okay? Where I'm going to find two x's at a certain y. So we now just can plug that directly in. So the h plus or minus, so 3, and I'm going to take the actual value of the h, so positive 3 plus or minus negative 4 divided by negative 0.25. So 3 plus or minus square root of 16. And then 3 plus or minus 4. Now I can split it off. 3 plus 4, 3 minus 4. I can reject the negative 1 and accept the 7 because what I'm looking for right now is determine the elapsed time from the moment the stone was at a height of negative or 2.25 meters during its descent, so on its way down. So they're saying here 7 seconds, 2.25. I don't care about this one over here because it's just not part of the question, right? Or not part of the answer. So what did I do in this guy? I wanted to use a formula. I used the rule that I was given in vertex form. I plugged in a y and set it to 0. I took the a unchanged, h unchanged, and a modified k and plugged that guy in. And then solved for it. It spit out two answers. So that is your option 1. Any questions on that?
So, sorry, I was just doing it like when you were explaining.
Yeah.
So, because we got the K, what is that, like, X with the S on it there?
Oh, so I'm just saying I'm solving for x's.
Oh.
Yeah, sorry. So it's just saying it's not, traditionally we use this guy to find zeros, But really, this formula can be used to find any x value at a certain y value. We just have to put the work in ahead of time. I've got to move that y value over, modify the k. Then when I plug it in,
Okay.
right? Because in fact, if I put negative 6.25, if I just left the original k here, negative 6.25 divided by negative 0.25, you know what it would give me? It would have given me my two zeros. It would have spit out negative 2 and positive 8. Because this formula can be used to find any x value given a specific y value on a function. That's the hardest part of the year right there. So if you can wrap your wee brains around this, then you're laughing. If you don't like this method, if you are a PHS algebra, sorry, let's do that. Option 2. So this guy here will just say, that's just the formula. This is algebra. Okay? So we start at the same point. 2.25, I'm plugging it into the vertex form rule, squared plus 6.25. Okay? So no difference in starting out. Okay? Now, here's the only thing that's different. Instead of setting to 0, we're going to get the k out of the way first. We're going to now work our way into that x. So instead of bringing this guy this way, we're going to bring the 6.25 this way. So it's a little bit backwards. So get that out of the way first. Okay? So negative 4 is equal to negative 0.25 x 25 up x minus 3 squared. Okay? Get that arrow out of the way a little bit there. Where did you stop? So brought that guy over there. Now this is what I'm left with. Okay? The next stage, again, I'm working my way in towards the x minus 3 squared. Like, my goal is to try and isolate for that right there. Because that's the ugliest part of this question right now. So I am going to divide both sides by negative 0.25. 16 is equal to x minus 3 squared. Okay? You'll notice it looks really similar to the formula I was working on now. There's some common numbers here. Right? What would I do now? What's the most annoying part? The squared, yeah, Alex? So square rooting both sides, I'm going to end up with 4 is equal to x minus 3. Where are you going to screw this guy up? The formula is nice because it tells you plus or minus. This process here, it does not say it. You just have to know that at this stage, when I take the square root of 16, because I'm dealing with the parabola, because there's two potential answers, and because there's two ways to make 16 with its root. I can have positive 4 times positive 4. I could have negative 4 times negative 4. I don't know which one it would be. So because it can be both things, we would then, again, split it off here. So I'm going to have positive 4 is equal to x minus 3, and I'm going to have negative 4 is equal to x minus 3. Bring it over, x is equal to 7, x is equal to negative 1. Same answers, okay? I just was able to reject one and accept another, okay? So you have to decide at this point, what format do you think you'd prefer to use? And I venture to guess, I would just try one or the other. I would try both of them, and then just you kind of get a feel for it. You'll know, yeah.
How did you get You know the first one with the formula, how did you get it to be like that with the line? Because isn't H3 and what?
So you're saying right here for this guy?
No, up a bit. Like when you're just turning it into like just putting the numbers.
Putting this in here, so the x minus 3?
Yeah.
You're saying, why is it minus 3? Because whenever I inject him in, what's the real value of that guy? The real value is 3.
But it's just, I, yeah, I guess, I don't know. I guess because H was in front, I was just.
Oh, like H was in front in the, so this, I see what you're saying. I see the confusion there. What did I do? This was the formula I wanted to use. I had to set things up ahead of time. So I went to the rule. The rule in this case is y is equal to a, x minus h squared plus k. I have to start with that. Okay? In this case, I know I'm looking for an x. I have a y. Sorry, I have a y that I was given. Say, what is the x at a certain y value? I found the a, found the h, found the k. So once I plug in all the things that are known, then the only thing left is like the x.
So you don't use the formula, you use the rule.
So, that's a good way to put it. I'll put it this way. You have to start with the rule so you can modify k so that I can then plug it into the formula. So yeah. So I started with the rule, moved the 2.25 over, okay? Set it to 0. Now at this stage, I leave the rule and I go to the formula. So I plugged it in down there. So that formula being plugged in down here, yeah, I can see how that would be confusing. Yeah, I use the rule to find the AHK to get it set so that I can put it in that formula. I guess is the better way to put it. So that's why this one I find can be confusing because you're switching between the rule and the formula, right? Whereas this guy here is just straight algebra nonsense. You just have to remember that guy right there. There's no one right way. There's not even one that I would suggest more to do over another. Every year it's like 30-70 and it switches. 30% of the kids like this, 70 like this, and then the next year it's 70 like this and 30 like this. There's no rhyme or reason. It's just whatever clicked, whatever makes sense. So I'll put both of those guys in there as options for how I go ahead and solve it. And I might end this video here on this one.